Hey everybody, I'm Chili. Welcome back to Beginner C++ Tutorial 11. Now there's been a change of plan. I'm splitting up the material for Tutorial 11 because it ended up being like over an hour when I recorded it. This deal's getting worse and worse all the time. So today's topic is references.
I've fallen and I can't get up.
It's an older reference, but it checks out. As a little bonus, I'm going to show you how to use some useful stuff in the Chili framework, like the color class and how to do mouse input. So let's get right onto it. In the tutorial 10, in the homework, I gave you the mission, and your mission was to draw the rectangle. So we're going to start off with that code. If you don't have it for whatever reason, you can get it on the wiki. It's no biggie. So this is what the code basically looks like. You got a loop inside a loop. You're going to draw the rectangle. It's all good. What we want to do now is we want to give this routine its own function. Well, let's take a look at what it looks like. Let's just run this mother. I don't know why I set it to release, but I did. It's a thing that I did, and now it's done. Here we go. So you got your rectangle, right? And what we're doing here is we are drawing it basically based on a position, X position, Y position, and on the dimensions of the rectangle, the width and the height. Now that's one way you can draw a rectangle. The other way you can do it is you can specify the corners. So you can specify the top left and the bottom right corner and draw it like that. And that's what we're going to do for our function. Now, I say let's make a function. Where do you think you're going to put it? I would imagine maybe a lot of you would think to put it in here, in game. But let's think about this. The draw rectangle function, this is a basic general graphics routine that you're going to use in lots of different applications that you make. So what I propose is that instead of putting it in our game class, we put it in graphics class because it is a graphics operation. So we'll go void draw rect. We'll pass in 4 parameters for the top left point and for the bottom right point. And then we're going to pass in the color, but we're not going to do RGB, 3 integers. What we're going to do is we're going to use the color class. So we're going to pass in a single object of the color class by value. And then we're going to put a semicolon here. And now we got to implement this motherfucker. So we're going to create definition here. We'll promote that to a document. And we just want to copy paste out this stuff here. So we'll copy that. We'll go back and we'll paste it in here. All right, and now we got to change some stuff. So the start position of the loops is just going to be the position of the top left corner. And the end value of the loop, the ending condition, is going to be the second point. All right, now I have a little challenge for you. What I want you to do is, we've got a problem here with graphics. It doesn't like it. So I want you to figure out why we have a problem and what you have to do to fix it. All right, did you figure it out? Well, here it is. Graphics is undefined because there is no graphics. We're writing a member function for the graphics class, right? But there is no member called GFX in this whole class. GFX is in the game class, but we're not writing a member function for game here. So there is no GFX. So what do you got to do? Well, we don't need GFX because we are the graphics class. And so all we have to do is call putPixel without specifying any object. When you are in a member function, function calls are assumed to be of that class. So this is going to call putPixel from the graphics class. You don't have to specify gfx.putPixel. All right, now let's go into game.cpp, and now we got to replace this with a function call to graphics.drawRect. And we're just going to pass in xpos and ypos for the first point, and for the second point we're going to put in xpos plus width and ypos plus height. Now the final parameter is color. So what we got to do is, well, one way we can do is we can create a color object, and then we can set the channels of that object. So we can set we can do c.set r, and we can set red to 255, and we can do the same for green and blue, and then we can pass this color object on to draw rect, and that'll work fine. All right, let's test it out and make sure it works. Here we go. Well, we're drawing the rectangle and we can resize it, so that's fine. But the color, it's white, and I mean red and green do not make white, they make yellow, I believe. So something's fucked up. Let's go back to graphics.cpp and check it out. And here we see, okay, yeah, I fucked it up because I'm taking a color parameter here, but I'm just passing 255s to putPixel. So we want to pass color into putPixel. Remember, there are two versions of putPixel. There's the version that takes, where is it? The version that takes RGB, and then the version that takes color. And if you want to know, the version that takes RGB just calls the version that takes color. So it takes these RG and B, it creates a color object, and then it calls color. So now that we've made it so that it actually uses the passed in color value, things should look a little different. Yeah, here we go. Okay, now we got our yellow rectangle. Now this ain't the only way you can use color. You can also do something like this. You can pass the values into the constructor like this and create a color that has those values for its channel. And I've also created a list of predefined colors, and you can do that by accessing the colors namespace. So you type colors and then double colon, and then you've got a list of colors in here, and you can pick one like, you know, I don't know, magenta. And that's like the ugliest color in the world. But there you go, you got your magenta rectangle. It's all good. But yeah, that's the colors class, and we're going to be using it mainly because it's cleaner and it's probably a little faster too. Not a big deal either way though. All right, so that is our function written. Now what I want to do is I want to be able to control the rectangle with the mouse. So first things first, we are going to change the variables here. So we've got X position, Y position, and width and height. We're going to change that 2 points. So X0 and X1 like this. And we're also going to change the second point. Obviously, if the points are all the same, you're going to have an invisible rectangle. And so we're going to change these ones to 200. Well, I guess we got to rename all this bullshit. And now comes the interesting part. I want to keep the control of the top left point by using the keyboard. So we'll replace these position with just, you know, Y0, X0. And then we're going to delete these ones because there's no more width and height. And instead, what we're going to do is we're going to control the second point with the mouse. So what we're going to do is we're going to check to see if the left mouse is currently being pressed. So if window.mouse.left is pressed, and inside the code block, we're going to set the position of the second point equal to the position of the mouse. So window.mouse.get position X. And do the same for the Y. And there you go, Bob's your uncle. If we run this stuff, there we go, we got our rectangle, and we can move the top left corner with our arrow keys. And if we click down, we can drag and move our rectangle around. Wherever we click, there our second point will be set to. And that's awesome. But there's one thing that just irks me just a little bit here. So if I drag it up above the position, this is point 1, right? Or point 0, point 1. If I drag point 1 above point 0, rectangle disappears. I can't drag it up into here. But I want to be able to draw my rectangle up here too. So, what do I have to do in order to enable that functionality? Well, first, it's kind of important for us to understand why the rectangle disappears when point 1 is above point 0. So you look here, we've got our loop here. We're looping first through Y, and we're starting at point 0 and looping until we reach point 1, adding every time. As soon as we are above point 1, we stop and we exit this function. Well, the problem is here, if point 1 is above point 0, the first time we enter this loop, Y is going to be greater than Y1, and so we're automatically going to exit, and we're not going to draw a single pixel. So the loop is going to exit even before it completes its first iteration. Now what we want to do is we want to be able to draw our rectangle regardless of the relative positions of point 0 and point 1. So if point 1 is above 0.0 in the y space, we should still be able to draw. And the way we do that is, well, right now we're drawing from 0.0 down to 0.1. What we should do is we should check to see if 0.0 or 0.1 is above 0.0. And if 0.1 is above 0.0, then we want to draw from 0.1 down to 0.0. Now, one way we can achieve that is we check to see if y0 is greater than y1. And if y0 is greater, we can swap them. So we can put the value of y1 into y0 and the value of y0 into y1. And now we'll be looping from the lower one down to the bottom one. So as long as we test and swap, we can use the same algorithm no matter what the position of the points are. And we'll do the same for x. So we're going to do a test and swap operation twice. Now, what I want to do is, because we're going to be doing this operation twice, let's create a function that will do that operation for us. So we'll go into graphics and we'll just create a function here. Void test and swap, and we'll go int a and int b. And we're going to create definition here. And let's see here. So first things first, we check to see if a is greater than b. And if so, we go constant int temp is equal to a. So we store whatever is in a temporarily in temp, because we're going to be assigning b into a. So whatever was in a is going to get lost unless we keep track of it. And then we take that value that we temporarily stored and we put it into b. So the end result is a and b's values are swapped, but only if a is greater than b. And then we're going to do that up in draw rect for x and y. And that'll look something like this. And this should work nicely. It should reorder our x's and our y's so that we're looping from the lower one, the smaller one, to the larger one. And we're looping from the smaller x to the larger x, like this. And so this should allow us now to draw any rectangle we want. Yeah, no, it doesn't. Of course it doesn't. Well, fuck me. So we can run the debugger on this and see what's going on. We'll just start the debugger. Here we go. We'll set it up so that the y1 is going to be less than y0. And then we'll pause and we'll go to graphics. So we are in graphics. Let's find our draw rect, put a breakpoint here, and then we'll continue. Hit the breakpoint. All right. So now x0, x1, that shouldn't be a problem. We didn't set those. y0, y1. Okay, so y0 is 100, y1 is 38. So this should swap them. And it doesn't. It doesn't do anything. Jack and shit. So let's continue again to the next frame. And let's step over and let's step into test and swap. All right, so a is equal to 100, b is equal to 38. That seems about right. A is greater than b. It is. So we set temp. So remember, a is 100, b is 38. We run this code. Now, a is 38, b is 100. So we did swap them. A and b were swapped. But when we leave, the order of y0 and y1 hasn't changed one bit. Well, what the fuck? Now, I'm sure some of you already know what's going on because I've already mentioned this issue before. Basically, when you call a function, let's say you call a function with y0 and y1, what happens is that function isn't acting on y0 and y1 directly. What's happening is you load the value of y0, you load the value of y1, and then you pass those values to test and swap. Those values get stored into local variables A and B of test and swap. And then when you operate on them, you're operating only on the local copies of A and B. And yeah, so you swap them, but that doesn't mean shit for the variables in here. There is no connection. They just happen to have the same values because the values loaded from y0 and y1 were stored in A and B. But there's no connection between these variables, so you can't have test and swap. Well, I guess we are fucking boned then, aren't we? Or so the Germans would have us believe. Now time for something completely different. It's the Halloween season here as I'm recording this, so let me show you something spoopy. What I'm going to get you to do is create an int, we'll call it v, and we'll set it to 69. Now create another thing, type in int, and then type in ampersand, and we'll call this r, and we'll set it equal to v. Good? Are you with me so far? Now we're going to do r plus and equal 420, and we're going to do v minus and equal 69. Now, let's see what happens when we run this bullshit. All right, so we got our debugger all hooked up here. V is currently set to some bullshit number value because it hasn't been initialized yet. R is weird. It's got like a weird X on it. I don't know. Let's step over, shall we? So we step over, we set V to 69. So far, so good. Now we set R equal to V. Now it's equal to 69. Okay, that makes sense, right? Now let's add 420 to R. And holy shit, it just changed both of the variables. Ooh, spooky. And if we subtract 69 from V, we get it. Again, it happens to both of them. What black magic is this? Whatever you do to R also happens to V and vice versa. So here's the deal. This declaration int ampersand here, this does not create an int variable. It creates a reference. It creates a reference to an integer. And this equals V is saying, okay, this reference R is going to be referencing the variable V. Now, a reference isn't really like a normal variable. You can think of it like, I don't know, like an alias or like a remote control. It gives another way of accessing the variable V. So if we are doing something to R, we're actually working on V. In other words, it allows you to manipulate a variable indirectly.
Dance, puppets! Dance!
Now, a reference has to be initialized to a variable. Otherwise, it makes no goddamn sense. It only exists to reference something else. So if you try to just declare int reference R, nothing. You can't do it. It requires an initializer. And if you try to initialize it to like a value, like let's say 20, again, you're going to get an error because that makes no goddamn sense. The only thing the reference does is it attaches itself to a variable. And once initialized, it acts exactly like a normal variable in syntax. They're virtually indistinguishable. So now you might be thinking, okay, Chili, so what? Why would I need two names for the same variable? That's just confusing. Here's where things get interesting, because we can use references in function parameters, and this is called passing by reference. So what we can do is we can take our test and swap function here, and in the parameters, we're going to put a ampersand in front of the type name. And then we're going to switch over to here. We got to do the same thing in the implementation. We got to make sure they match. And if we do this, we don't have to change anything else. And let's run the program and see what happens. Oh, I don't want this fucking breakpoint there. Did I save it? Here we go. All right. Now if we move it above, holy shit, it motherfucking works. Would you look at that? Don't go off the screen though, because it gets fucky, but doesn't matter. It works. Eureka. It's pretty cool. It's cool when shit works, right? I think so. So what's the deal? Well, because we're now passing in x0 and x1 by reference, A and B are actually just different names now for x0 and x1, or y0 and y1, depending on what was used to call the function. And so you can use A and B to remote control these guys. So when you swap A and B, you're swapping x0 and x1, or y0 and y1. And that is one of the true powers of passing by reference. You can actually control the values of the parameters that you are passing in. Now, as I've already gone over many, many times, a normal function call passes a value, right? And you might ask the question, okay, so what is being passed in this situation here when we're using reference parameters? What's actually being passed from the caller to the callee? And the answer is, well, You see, each variable exists in a specific location in memory, and every location has a unique number associated with it called its address. And it's that address that's being passed to the function. And the address is the thing that the reference uses to remotely control the variables and access them. If you have someone's address, you can fuck with them. Just ask any Twitch streamer. Now, if you know anything about pointers, all this talk about addresses might sound familiar. And references are basically pointers dressed up and, given a shave. Think of pointers like the crazy coke-snorting, promiscuous party people. They can be fun, but they might also give you the bad aids. Now, to be honest with you, normally I wouldn't make a separate function just for this bullshit here. So we can, delete this, and we'll go into test the swap, we'll delete that, and fuck, no, fuck you. All right. And so what I would normally just do is I would just go, if x0 is greater than x1, and then I would just swap inside the if statement. Now there is a thing in the standard library. There's actually a function called swap. And interestingly enough, if you look at the function here, you can see that you see these ampersands here. So the swap function, the standard library swap, also passes in by reference because, that's the way you do it. So we can just call swap and we go x0, x1, and that'll get us the same thing there. And we can do the same for y0 and y1. And if we run it, there we go. No problem. All good. Okay. We are now able to do something in the poo game that I wanted to do before but wasn't able to. So go back to the poo game, and if you don't have it, you can download from the wiki page. So what I want to be able to do is I want to make the poo class responsible for drawing the poo object. Right now, the poo drawing code is just floating around in game, but I want to bind that functionality to the actual poo object. So, let's just see what we can do here. What I want to do, let's go to poo.h, and we'll add a function. We'll call it void draw. We'll just start off with draw. And then we'll create a definition of draw. And what we're going to do is copy the code from game.cpp. So we'll go draw poo, cut that out, and we'll paste it in here. And then what I'm going to do is promote this to document, and we got a whole bunch of bullshit here now. So it's not game, it's going to be poo, not plu, it's going to be poo. It's gonna be me. There we go. No parameters, that should work. Yeah, that has linked up with the other version. But the problem is we don't have any graphics, right? We don't have access to graphics because graphics is a member of the game object. So the problem is, this is the reason why I couldn't do this before. We didn't have any access to graphics. Now, you might say, well, Chili, what if you just pass the graphics in by value? So we do graphics like this, and first off, function has to actually know, or not the function, this file has to know about graphics. So we can go include graphics.h, and then we're going to go over here, and we're going to go graphics, GFX, and all right, that makes this happy. This looks fine. Looking good so far. Let's go to game, and let's find out where we actually draw the poo. So that's going to be in compose frame right now. Why is draw? I said compose frame, bastard. All right, here we go. Draw poo. So instead of doing draw poo, we're just going to do draw on the poo objects like this. Poo0 draw graphics. And here we see right away we get an error, GFX, and cannot be referenced deleted function. And this probably doesn't make any sense to you whatsoever. But the reason why we can't do this is this function that it's saying here, it cannot access. This function is the copy constructor. This is the function that gets called when you try to make a copy of an object. So when you try to pass graphics by value, you're going to make a copy of it to copy it to the local graphics variable in the function, but you can't copy. You can't copy graphics. It doesn't make any sense. Think about it. Graphics represents the actual window, the screen of our window that we're drawing to. There is only one of those. You can't make a copy of it. It doesn't make any goddamn sense. And that's why we can't pass graphics by value. But what we can do is we can pass it by reference. So put an ampersand here and toggle header and code file. We'll go to draw. We'll put an ampersand here. And there you go. Bob's your uncle. And this should work. Let's go back to game. No more tears. Let's go to these guys here. We'll change it to poo1, poo2. And if we run it, it will work. And here you go. No problems whatsoever. And now we have our drawing code inside of poo where we like it. Now there's another function I see here that could use a little pass by reference love. And that function is process consumption. I see we're passing in a whole bunch of different values, but they're all related to the same dude. So instead of passing in 4 different values like this, why don't we just pass in a reference to dude? So we'll just pass in dude, reference, dude. Now, this thing doesn't know about dudes, or at least it probably doesn't know about dudes, so it's safe to go into here and include dude.h so that it'll understand what a dude is and how to abide and so forth. So now we're going to toggle, get rid of that. So process consumption. So now we've got I should have copy and pasted that. So we set the single parameter in by reference. That makes this underline go away, and it makes a whole bunch here. But this is really easy because of the way I named them. All you got to do is put a dot in here and in here, and it's all good. Oh yeah, and here, here. That's it. There we go. Sweet. And if we try to build it, we see, yeah, we got a problem here because the place where the function is being called, it's using the wrong parameters. So we just change it and pass in single dude every time. And now if we build this, no problems. All good. Now, here's the thing about passing in the dude into the process consumption function. Technically, we don't even need to pass this one in by reference. We could pass it in by value. We just build that. Oh wait, fuck. And I gotta change it in the implementation as well, like this. And so we build that, and that works fine. There's no problems. That'll run. So yeah, because you can make a copy of a dude, the dude, and when you copy the dude, all you're going to copy actually is the X and the Y. But in general, your entities, your objects in your game are going to have a lot more variables than just, 2 ints. They're going to have maybe like hundreds of bytes of data. And so if you pass them by value, you have to copy all that data. And that can add up quickly to make your program as slow as fuck. So in general, when you're passing objects, you're probably going to want to pass by reference. Now, one final thing I want to show you guys here, and this is kind of important. It's a very good practice to learn, and that is, I've mentioned it before, it's called Const Correctness. And basically, in the process consumption function here, we're passing dude by reference, but we're not doing that because we want to change the external dude's values or anything. We're just reading. This is a read-only operation. We're only getting information from dude. And if we're doing that, you should always make it so that the reference is a const reference. So const dude ampersand this. And you got to do the same thing over here. And what making a reference const does is it says, I am not going to change any of the values in this object. I'm only going to read. It makes this a read-only reference. And that's good because we are only reading. So what this does is this makes it so that you can't accidentally, maybe change something that you weren't intending to change. And, that's good. Anything you do to reduce the chance of an error, a bug creeping into your code is a goddamn good thing. This is also communicative. if you have a function and it has dude ampersand, the person who passing dude in is going to assume that you're going to try to change dude. So if you put it const, now the person calling this function, looking at the function, can say, oh, he's just getting information from dude. He's not going to change it. And that changes the way they write their code. It's a kind of communication. Very important. So always, if possible, make your references const. The only time they shouldn't be const is, for example, with our swap function, if you have to change it. You can't make, by the way, you can't make this one const because graphics, we're calling putPixel, and putPixel is actually changing the graphics function, is mutating that. So you can't pass graphics in with const. You have to pass it in just a standard reference because we are doing something that will affect the graphics object. But there is something else we can do for this draw function. So draw function, it affects graphics, it mutates graphics, so we can't pass graphics in by const. But the draw function doesn't affect the poo class. It doesn't affect any of x, y, vx, vy. It only reads these values. It doesn't change any of them. And if you have a member function that does not change any of the members of the class, you can make the member function constant. And that's saying this function doesn't change any of these members. It is not a mutator, right? Process consumption, update, they change these variables. So they are called mutators. But this is a non-mutating member function. So we specify it with const at the end. And we toggle here. We do the same thing here. Const. Wait. No, it was draw. It was draw. My bad. Here we go. And it's the same idea as with constant references. It helps prevent you from fucking yourself over, helps prevent other people from fucking you over, and it is a good communicator. It says, oh, this function is not going to change any of the members of the object on which it is called. Good to know. So to recap, there are basically, you can break it down to two usage scenarios where you want to be passing by reference. Scenario one is you can't or you don't want to copy an object. And that would, graphics here, the draw function would fall under that case. We can't copy graphics, so we have to pass it in by reference. And for the dude, it's the same idea. We could copy it, but we don't want to. We want to pass by reference because we don't want to copy all of its members. Like I said, in this case, it's only 2 members that are being copied, but in general, it's going to be a fuck lot more. So when you're passing your objects, you pass by reference generally. Now, the other usage scenario is pass by reference because you want to be able to modify remotely some variable outside of the function. And again, draw falls under this category because we want to be able to modify graphics. We want to call putPixel and change the contents of the screen. Another example of this one would be our test and swap. We want to be able to swap those external variables, so we had to pass by reference. So 2 usages, can't or don't want to copy, or want to be able to modify some variable outside of the function. Now, as for passing in by value, you generally pass things like, single integers and Boolean, stuff like that, in by value. There are cases where you want to pass in objects in by value, and one example of that is if you look at our drawRect function here, you see we're passing color in by value. And the reason for that is if you look at the color object itself, it only has one data member, and that data member is a single integer. So you're better off passing this one in by value because you're only passing in one integer, right? It's no different than passing in a single int. And when you're passing in a single int, you prefer to pass in by value. But for heavier weight objects, definitely pass by reference. All right, now it's time for the homework. I've got 2 tasks for you this time. First task, you can probably guess, but we moved the drawing code for the poo into the poo class. Now I want you to do the same for the dude. That is task number 1. Task number 2 is I want you to create a second DirectX function, and this one is going to take a single point plus the width and the height. So it's not going to take 2 points, but it's going to take a single point and then the width and the height. So create a second version of the DirectX function, and it's up to you as to how you're going to accomplish that. As usual, I will give you my solution in the next video. But until then, that's tutorial 11. Leave a comment here. Let me know what you think. I'm always interested in hearing your feedback, making better tutorials and all that bullshit. But until next time, thanks for watching, and a special thanks to all my Patreon supporters, and I will see you soon with some more C++.